Hey, honey, the eggs are expired. Are they safe to eat? An everyday use of physics in the home. So checking to see if your eggs are still good isn't as easy as looking at the date on a carton. You could have an expiration date, a use by date, or a sell by date. And it also probably has something called a Julian date, which is a 3-digit number indicating when the eggs were packed. If the number is 005, for instance, they were packed on the 5th day of the year, January 5th. As you can see in the photo, this carton I pulled out of my fridge has some random unlabeled date on it. People in many other countries don't even refrigerate their eggs. Are they really bad based on a date stamped on the carton? Confused? Not to worry. Physics is here to save the day. The egg float test. How does it work? Fill a glass with cold water and place the egg inside. If it sinks to the bottom, it's still good. If it's touching the bottom but looks like it's starting to rise up just a little bit, cook it up and eat it very soon. If it floats, do not eat the egg. It's bad. So why does this work, and what does this have to do with physics? Let's explore the whole idea of sinking and floating. Going back in time over 2,000 years ago, there was a brilliant Greek mathematician, Archimedes. He was also a great inventor, astronomer, engineer, and physicist. Born to an astronomer father, Archimedes went on to study mathematics in Alexandria, Egypt. King Hiero II of Syracuse often consulted with Archimedes. Legend has it that the king suspected a goldsmith of diluting the gold used in making his crown with some silver, and he brought up his suspicions to Archimedes. While mulling over the problem in the public baths, Archimedes is said to have observed the water rise from his bath as he got in. The moment of inspiration hit Archimedes. He noticed that the volume of water that rose was proportional to the volume of his body that he submerged. He knew that this was the key in solving the king's dilemma. Energized with excitement over this revelation, he rushed into the streets, still unclothed, shouting, "Eureka!" or "I found it." Using a piece of pure gold weighing the same as the crown, Archimedes was able to measure a difference in the water displacement for the pure gold piece versus the crown, thus proving the lack of purity in the crown. Although the accounts of this story vary and the historical accuracy of various parts of the legend is questioned, it is undisputed that Archimedes' contribution to the study of floating and buoyant forces is truly significant. The Archimedes principle. A body immersed in a fluid. No, not that body. Let's try this again. The Archimedes principle states that a body immersed in a fluid is subjected to an upwards force equal to the weight of the displaced fluid. More on floating in a bit. Let's get back to our eggs. What happens when an egg ages? When an egg gets older, the decomposition process gives off some gases. Got it. So the egg fills up with gas, and gas is lighter, so it floats away. No. When matter changes its state, its mass doesn't change. If the gases are contained within the egg, it still has the same mass. The size of the egg doesn't change, so it has the same volume. And if the mass and volume are the same, then the density hasn't changed at all, and the egg wouldn't float. What really happens? An egg shell is a semi-permeable membrane. Some of the gas molecules are small enough to escape through the shell. This leads to a smaller mass within the eggshell. We know that an object's density is its mass divided by its volume. The volume of the egg stays the same, which means that the density of the egg decreases. Egg number 1. When the density of the egg is more than the density of the water, the egg's weight, which is the downward force, is greater than the upward buoyant force, and the egg will sink. This is a good egg with little or no decomposition. Egg number 2. When the density of the egg starts to decrease, it starts to rise off the bottom of the glass. It will not float yet, but it will show more of the buoyant force acting on the egg. Okay, with the various eggs that were left outside, overnighted in the garage, and kept in the car on hot Texas summer days, none of them were at the correct state of decomposition to demonstrate this particular condition. In case you were wondering, this is not a real egg. But if this egg was a chicken egg and not made of plastic and $1.28 in coins, and it showed this amount of buoyancy in water, it would be good, but you would need to eat it very soon. Egg number 3. If the density of the egg is equal to the density of the water, then the weight of the egg, the force downward, will equal the buoyant force pushing the egg upward. It will then be suspended and completely submerged. If you push down on it, it won't necessarily feel like it's pushing back on you. It'll go in the direction you've pushed it, but it'll slowly find its way back to the middle again. It's probably not rotten, but the egg is still showing you that its mass has decreased significantly. It's too old, throw it out. Egg number 4. When the density of the egg is less than the density of the water, the buoyant force will be larger than the weight of the egg when fully submerged. The net force acting on the egg will be upward, and the egg will float. If you push down on the egg, the buoyant force will push it back up. When it reaches the surface of the water, just enough of the egg remains submerged so that the weight of the water displaced by the submerged portion of the egg will equal the weight of the egg. At this point, the net force is 0 and the egg is at equilibrium. This floating egg is bad. Don't eat it. Warning. Although some gases escape through the eggshell, many of them don't. The stinky, rotten egg smell isn't just unpleasant. Hydrogen sulfide is flammable and toxic. Carefully dispose of bad eggs. So, to answer that question, hey honey, the eggs are expired. Are they safe to eat? The density of the egg is greater than the density of the water. The egg sinks, it's good. The mass of the egg is getting smaller, so its density is getting smaller. It's obviously more buoyant, but it's still safe to eat. Eat it soon. The mass of the egg has now decreased so that the density of the egg is equal to that of the water. It is now suspended in the water, completely submerged. It may not be rotten, but it's far from fresh. It's bad, and you should probably toss it. The mass of the egg is now small enough that the average density is less than the water. It's bad, throw it away. Remember, an egg that sinks doesn't stink, but a floating egg, please toss, I beg.